In this lecture, we look at angular velocity and angular acceleration as vectors. Here we have a particle that's traveling on the dotted path, and the angular velocity, the magnitude of it, is equal to the time derivative of the angle. Here the dot is going in a clockwise direction around the z-axis, and we are going to define, using the right-hand rule, the direction of the angular velocity vector. You curl your fingers of the right hand in the direction of rotation, and the thumb will point in the direction of the angular velocity. So it's pointing down the negative z-axis. So down is equal to counterclockwise, or the minus z direction. Up is equal to counterclockwise, or the positive z direction. Angular acceleration gets its definition or direction from the definition of the angular acceleration as the time derivative of the angular velocity. The direction is the same as the direction of the change in the angular velocity. This is the difference between omega final and omega initial. So if we have an omega initial that points up and an omega final that also points up, but omega final is smaller than omega initial, the change in delta omega is downward, so in the minus d direction. Or if we have a small initial omega pointing up and a larger omega final pointing up, then delta omega points up also, and that gives us a plus z direction. If omega initial is pointing down and large compared to an omega final that's also pointing down, then delta omega will be pointing up, and that gives us a positive z direction. Finally, we have a small omega pointing down and a large omega final pointing down. So delta omega will be pointing down, and that gives us a minus z direction. Let's look at an example of the direction of omega and alpha for a wheel. The wheel spins in the direction shown by the white arrow. Using the right-hand rule, which is the direction of the angular velocity vector? Is it A plus z or B minus z? Well, if you curl your fingers using your right hand in the direction of the white arrow, you'll find that your thumb points in the minus z direction. Sometime later, an angular acceleration occurs, and the wheel spins in the opposite direction, which is the direction of the angular acceleration. A plus z or B minus z? Well, now we know that the angular velocity has changed so that it's going in the other direction. So the angular velocity is pointing the positive z-axis. So the magnitude of the change must have been large enough so that omega final is much bigger than omega initial, and it's in the positive direction. So the change must be positive. So it's plus z. The vector description of angular velocity and angular acceleration becomes particularly important when the axis of rotation is free to move.